Chapter 4, Section 15. Common pitfall in outlier detection. In the previous video, we talked about the primary method for detecting outliers. We can detect outliers using statistical method while also using knowledge and considering the goals of the analytics. Common statistical method for outlier detection include z-scores and the Tukey method with the IQR. And we can use visualization techniques such as box plots and histograms to check whether outliers exist in the data. However, entirely relying on these methods can be a pitfall in outlier detection. While the methods explained above are generally correct as a foundation, simply using them all the time can sometimes result in failing to detect outliers properly. The most commonly used statistical method for outlier detection is the IQR method. Let's see this example. In this case, the IQR method only detected one outlier, which is a data point with a value of 1000. However, there are 10 data points in this data, half of which have values between 120 and 160. So, 25 and 30 are much smaller than these, and they also appear to be outliers. In addition, the values 370 and 540 also appear to be quite large in this dataset. Why are these values not outliers? This is a pitfall that analysts often fall into when detecting outliers. We have already calculated the IQR on the dataset that contains outliers. Let's visualize the data using a strip plot. On the left side of the figure is the original dataset. The data point with a value of 1000 is far away from the others. The right side of the figure shows the data distribution, where the outlier with a value of 1000 have been excluded. Now, it appears that there are outliers in the data points that were previously seen as a single set. In this way, if extremely large or small outliers are included, even if there are other data points that should be considered outliers, they are less likely to be detected as outliers. In such cases, we should exclude the initially detected outliers and then recalculate the lower and upper bounds and detect outliers again, using the revised lower and upper bounds. The method based on this idea is the iterative method. This method detects outliers, excludes them, and repeats the recalculation. First, outliers are detected by calculating IQR or standard deviation. Then, after excluding the outliers, the IQR or standard deviation are recalculated, and outliers are detected in the remaining data. This process is repeated until there are no outliers or until the change in the number of outliers is small. This allows for accurate outlier detection while minimizing distortions caused by outliers. Let's run the iterative method on the previous example. First, we deleted the data point firstly detected as an outlier with a value of 1000. And we created a new column, value 2, that consists of values of remaining data point. Next, we recalculate the IQR on this column to determine the lower and upper bounds of non-outliers. Then, using these lower and upper bounds, we detect outliers in the original data, the column value, and store them in the new column, outlier IQR2. Then, display the columns containing the original value, the outlier determination by ordinary IQR method, and the outlier determination by the iterative method. The result is as follows. The simple IQR method detected only one outlier, the maximum value. But when this outlier was excluded and explored the outliers again, 4 more outliers were detected, 2 with an extremely small value, and others with an extremely large value. Let's create a strip plot which shows the data distribution before and after the exclusion of the largest outlier. On the left is before excluding the maximum. Because the maximum value is extremely large, the variability of the other data points is underestimated and considered as a single group. The right side is the distribution after excluding the maximum value. Because the maximum value has been lowered to 540, the variation of these data points appears larger, and the variability between the data points around the median becomes clearer. In this way, the iterative method enables us to detect outliers more accurately. Let's define a function for the iterative method that repeats the IQR method until no more outliers are detected. In the first line, define the name of the function on the input. The first argument, df, is the data frame to be input. This is the data for which outliers are to be detected. The second argument, threshold equals 1.5, is the IQR multiplier for determining outliers. The third argument, max iter, is the maximum number of iterations, set to 100. The second line extracts the columns from the data frame to be used for outlier detection. The third line creates a new column in the data frame to store the outlier labels. Initially, input false for all of them. Next, iterate through the process using a for loop. Repeat as long as outliers are detected, but terminate the loop if the specified 100 time is exceeded. NumPy percentile data 25, 75 calculates the first quartile and the third quartile of the data. The IQR is then obtained by subtracting the first quartile from the third quartile. Next, calculate the lower and upper bounds using the IQR method formula. Then, the values that are smaller than the lower bounds and larger than the upper bounds are extracted as outliers. The next if statement, if outliers empty, break, terminates the iterative process if no outliers are detected. If no outliers are detected, outliers empty becomes true. In this case, the iterative process is terminated. The following line labels the rows where the if value is included in outliers as true in the outlier iter column. It identifies the location of the outlier. The next line removes the outlier from data. This line selects the data not contained in the outliers. This enables the next iteration to process again on data from which the outliers were excluded. The final line is to return the data frame, df, with the outlier labels. An outlier is a data point that is significantly different from other observations in the dataset. There is no strict definition of an outlier, and they are generally detected using visualization and a statistical method, also based on domain knowledge and purpose of the analysis. However, since outliers are determined by relative position and variability, an extreme outlier can make other outliers less noticeable. Thus, relying on simple statistical method can lead to overlooked data points that should be outliers. In this section, we have explored the iterative method as one of the methods to address this problem. The next section will discuss various methods to deal with this problem. Thank you for watching. Please thumbs up and subscribe to my channel.